What is aerospace engineering? With 8,100 satellites and nearly 25,000 aircraft flying around the world, you know the role of an aerospace engineer is something quite special. So at the core, an aerospace engineer would design something to fly. We're talking aircraft, spacecraft, satellites, missiles, yeah, that kind of stuff. Now, how it intends on flying is where it gets interesting. I mean, is the craft going to use jet engines or propellers? What about the fuel? Are we going for the classic kerosene or thinking solar panels and batteries? What about the passengers? How many? Is it over 500? Or are we just flying for one that's specialised in air-to-air combat? And the range of the craft? Are we travelling over 100 million miles? Or is it just over the ridge to get those breathtaking drone shots? These are the questions that engineers need to answer before any component is designed. Let's take the Concorde, for example. Now, for those of you who don't know, it was the fastest commercial plane to take the skies, reducing the London to New York flight duration to just 3 hours. It was at the very edge of engineering. Some would even say it was the Bugatti Veyron of the skies. But how can engineers just casually reduce the flight time by over half? Well, they're going to have to go all out, designing from the ground up. First, let's take the wings. The design concept for them were taken from fighter jets. Add the fuselage and another 5,000 hours of wind tunnel testing, and you have just the shape of the Concorde. But wait! That shape is for Mach 2 speeds when flying. What about takeoff and landing? Not only are the drag coefficients completely different here, but the pilot actually needs to see the runway. So what did the aerospace engineers do? They gave it a nose that could move up and down. It was simply incredible, cutting-edge technology. So why was it retired? Simply put, there wasn't enough demand for it. Passengers didn't want to fly with it anymore. There was pressure from all angles to stop the service. But what does this have to do with an aerospace engineer? They just design and build, right? Yes, they do, but they have to know who and what the craft is for. You see, following the horrific accident with the Concorde in July 2000, the events from the 9/11, and the deafening sonic booms, what passengers really wanted the most was safety, economy, and looking after the environment. So yeah, getting there fast is important, but so is making sure what you build is needed. And really, this is what aerospace engineers do. They consistently evaluate and assess the requirements, looking holistically at the design, who it's for, and specifically why. Take military aerospace engineering, for example. Here, the requirements are completely different. The importance for the environment and cost isn't high on the list. But the quality and safety of the pilot and the plane is crucial. The craft is engineered completely differently. I mean, it can get from NYC to LA in 40 minutes, but who wants to arrive in LA after exerting nearly 9 Gs with no luggage? It's not really suited for that. So how exactly do they think about all of this? Well, for them, it's about solving one problem at a time. For example, one of the biggest issues with space travel is galactic cosmic rays. Basically, ionizing radiation when travelling in space. Now on Earth, we are protected by our atmosphere. But in space, there's very little but the spacecraft protecting you from this radiation. So, it's thinking about new material that could be used, that isn't heavy and inefficient, like lead. The next problem? Power and fuel. We've all seen Apollo 13. Back down to Earth. Amazon wants to take their Prime services up a notch and drop off your parcels with drones. Sure, they have years left of testing, but what problems are they solving? Think about the integration with commercial airspace, or even the public. What will the public think about drones flying everywhere? Would you be happy with one hovering outside your bedroom at 7 AM in the morning? Depends if it's your parcel, I guess. But it doesn't always have to be about implementing extraordinary features of engineering. One firm decided to replace their pilots' paper manuals, which consisted of logs, maps, safety manuals, and replaced it with an iPad. Savings? $1.2 million in gas costs alone, not to mention the safety improvements. What about the 25,000 aircraft that circle the globe every day? Who's looking after them? What about the maintenance? I mean, Elon Musk and the other visionaries want to reuse spacecraft. Do you really think they'll let that rocket go back into space with just a new tank of fuel? Again, this is where aerospace engineers work their magic. But wait, you're probably thinking, why haven't I mentioned the electric plane? Shouldn't this be the way forward? Well, yes, you're right, but that's the beauty of STEM. They all rely on one another. The electric plane is waiting on much better batteries, and as for flying cars, let's master electric cars on the road first. There is so much to do, so why not get involved? I want to be able to get my parcel from Amazon in the morning without being woken up. As usual, subscribe if you loved the video, like if you liked it, drop us a comment below on what our next video should be, and Patreon for those who really like our stuff.